need to physically realize what it is that's going on and what it is that you're supposed to be finding. So first of all, it tells you that A, B, and C are on horizontal ground. So if I just highlight that in red, okay, so there's A, B, A, C, and that. You've got to imagine that that triangle is flat on the ground. And then this flagpole here, TX, is vertical. Okay, so it's sticking up from a triangle which is on the ground. We're told that C is east of A, and we're told that B is north. So this line and this line are at right angles to each other, which is why we've got a right angle triangle here. And it says that it just happens that the vertical flagpole, so this flagpole TX, the base of it is on this point here, so that this angle here, now this is just an imaginary line, doesn't actually, it's flat on the ground. So if I do that in red as well, this line here is also horizontal, and angle AXC is a right angle. So it just happens that there is a line that goes from there to there, so that that angle is a right angle. We're told the height of the flagpole is 10 meters, and we're asked to calculate the size of the angle of elevation of T from A. Now, if we look at this from the side, so here is the flagpole. Let's do that in green. So there's the flagpole in green with the flag on top. So that is T, okay, and that is X at the bottom of the flagpole. And somewhere over here we have point A, okay, which on this diagram is here. And if I go and do this line in red, we've got a horizontal line that goes from A to X. Okay, so this red line is horizontal. The green line here is vertical. So there's obviously a right angle here. And the angle of elevation of T from A, well, the angle of elevation is the angle. If you imagine you were standing at A, you looked at the top of the flagpole, it's the horizontal, it's the angle between this line here, this imaginary line, and the horizontal. So the angle that we're trying to find is this one here, which is theta. Now if I transfer it onto this diagram here, it's less obvious where theta actually is, but I'm going to draw a straight line-ish that goes from A to T, and the angle that we want then is this one here, which is angle theta. Now look at what we've got. The length of TX we already know is 10 meters. The one that we want, and remember, in order to do trigonometry, we need to know either the length of AT or we need to know the length of AX. So we need the opposite. So we're either going to have the opposite and the adjacent or the opposite and the hypotenuse. And I can see that this one here, AX, is going to be much easier to find because we can play about with the triangle on the ground. Okay, so let's have a strategy for finding AX. Now I can see what's not going to help very much. If we look at the big triangle, so triangle ABC, so this one here, if I found the length of BC, which a lot of you did, that's not going to be particularly helpful. I've got this one, 25 meters, and I should know that in order to do right angle trigonometry, this is the one I want to find, AX, I need to know the length of one side and one angle in the triangle in order to find another length. Now the trouble is, in this right angle triangle here, triangle AXC, all I know is the length of this side. And the same is true in this one here, ABX, all I know is the length of AB. But I could find this angle here. So let's call this angle here angle X. I could find angle X. Now the way that I could find angle X is looking at the big triangle. So if I look at the big triangle, which is triangle ABC, so there's B over there, and there's C, and there's A, that is a right angle. I know that that's 14 meters, and I know that this outside here is 25 meters, and I can work out this angle here, which is angle X. Now in order to do that, that's the opposite, that's the adjacent, so I can write that tan X is going to equal 14, the opposite, over 25. So to find X then, X is going to be the inverse tangent, or tan to the minus 1, of 14 over 25. And if we work that out, it comes out as 29.24 blah, 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 blah degrees. Okay, I'm going to save that in the memory of my calculator. I'll put it in my memory as A. Okay, so going back to the angle that I've now got, I want to find now the length of AX. Remember, if I can find the length of AX, then I'm sorted. So I'm just going to draw this part of the triangle again, where I've got the 25 meters here, I know that that angle there is x. So this is point A, this is point C, this is point X. I know that this angle here is a right angle, and this is the side here that I'd like to find. Let's call it Y. So this angle here, sorry, it's not X anymore. We know that this angle here is the 29.24. So again, I've got a right angle triangle. I know this angle here, so Y is the opposite. The 25 meters is the hypotenuse. So I know that I'm going to use sine. So I can now write my trig equation. So the sine of the 29.24 is the same as the opposite, which is y divided by the hypotenuse, which is 25. So multiplying by 25, y is going to be 25 multiplied by sine 29.24, etc. And if I stick that in my calculator, I get 12.215 meters. Okay, I'm going to put that in my memory, and I'm going to call that B in my memory. So I now know that AX is 12.215 meters. Okay, so going back to our original problem now, here we now know that this side AX is 12.215 meters. Okay, I've just drawn this triangle again. So the theta then is the angle that we're trying to find. In this right angle triangle, there's the right angle because it's the angle between the horizontal and the vertical. This is the opposite here because it's opposite angle theta. This is the adjacent, so this time I'm going to use tan, and I know this time that tan theta is the opposite, which is 10, divided by the adjacent, which is the 12.215 that I've saved in my memory. So I know that theta is going to be the inverse tangent of 10 over 12.215. Okay, make sure you keep accurate all the way along, and if I work that out, it comes out as 39.3058. Always write an accurate answer first, remember. Now round it. They ask for 1 decimal place, so the angle of elevation is 39.3 degrees.